Welcome back from an ad break. So now you're going to dive into our application questions. Again, they're based on the formation of rust and the prevention of rust. So let's start. We are given that we need to answer this question, that what is the chemical name of rust? So remember rust, it is now that reaction. We are getting rust when we are reacting our metal with our oxygen to form our iron oxide. So that is going to be iron oxide. Then question 2, list the important requirements for rusting to occur. So for this process to happen, the rusting, what is it that is needed? We need the metal, we need the oxygen, but most importantly, we need oxygen. We also sometimes need the moisture or water. Let's just say moisture. Moisture. So this is what we need for rust to happen or for rust to occur. So we need our metal. That metal needs to react with the oxygen. Now that is going to react with the oxygen. There must be moisture. Sometimes there needs to be moisture, sometimes it doesn't have to be moisture. So we need the metal with the oxygen, and when those two things react, they form the metal oxide, and that is what we know as rust. Now, moving on, we are given two equations now. We are asked to balance the following reactions that form rust. Now we can see that we have two similar equations. They both have similar reactants. Remember, reactants are written on the left-hand side and the products are written on the right-hand side. So on the first one, we have FeO2 reacting to form FeO. The second one, still the same reactants, FeO2, but the products, they are different. How is it that how is it possible that two substances that are the same, they react together to form two different things? We know that the product is always different from the substances that made it up. But in this case, the reactants are the same. How is it possible that they can form two different products? The reason is iron. We need to remember that iron, Fe, it is on the periodic table part of the transition metals. Transition metals. That means iron can exist in three different states. We can have iron 1, we can have iron 2, we can have iron 3. So what we have used on the first one here, we have used iron 1. So that means the ratio, when it reacts with something, it is going to be 1 iron in this case, it is going to be 1 iron to 2 oxygen. Whereas on this one, we have used iron 2. So we have iron 1. How do we write it? We have iron 1. And then if it's iron 2, it's going to be 2 Roman figures, the Roman figure 2. That's iron 2. If it's iron 3, it's going to be Fe123. So that's the difference. So now iron is found in the transition elements in the periodic table. That means it can exist in different states. We can have iron 1, iron 2, and iron 3. So therefore, that iron that we have used in these two equations is different from each other. So that's iron 1 and iron 2. So let's try to balance this chemical reaction using iron 1, and we'll try to balance this chemical reaction, our next one, using iron 2. And you will see how is it different in terms of the ratio. So to calculate or to balance this chemical equation, we need to calculate the number of atoms on the left-hand side and the right-hand side. They need to be equal. So by looking at this, iron, we have one of them on the left-hand side, we have one of them on the right-hand side. So the iron is balanced. But oxygen, we have two of them on the left-hand side, and we have one of them on the right-hand side. So to balance that oxygen, we need to balance it with a 2, because that's what we're trying to balance. So we're going to rewrite this equation again, reacting to form FeO. So we need to balance this oxygen so that it is equals to this one. In doing that, we're going to insert a 2 there. Remember that coefficient 2 goes for everything in this compound. That means now we're going to have 2 ions on the right-hand side and 2 oxygens on the right-hand side. So now the oxygen is now balanced. But it creates a problem with the ion, because on the left-hand side, I now have 1, but then on the right-hand side, I have 2. So to fix that, again, we just insert a 2 there, so that it balances out that 2 of iron and the 2 of oxygen. So we have 2 Fe, and then 2 oxygen, and then we have 2 Fe this side, and 2 oxygen on the right-hand side. So we can see that all the atoms are balanced on the left-hand side and the right-hand side. Now, using our next ion, ion 2, how is it different now? We're seeing that we have 1 Fe on the left-hand side, but we have 2 Fe on the right-hand side. So as we have said, the difference with these ions, ion 1, 2, and 3, is in terms of the ratio. On this one, the ratio was that for every 1 ion, we need to have 1 oxygen on the product. But then here, on the products, we have 2 ions, we need to have 3 oxygen atoms. So, but still it is not balanced. We have 2, we have 1, so we're going to rewrite this equation again here. We have Fe plus O2 reacting to form Fe2O3. So to balance, if I put a 2, because now I'm seeing that I have 2 ions here and then one ion there. If I put a 2 to balance that oxygen, that ion is taken care of, its balance. But then the oxygen is still not balanced. There's 2 and 3. So what can I do again? If I put a 2 again there, so I'm changing the number of molecules or the number of atoms of iron. It's going to be 2 times 2, which is now going to be 4. And then with regards to the O, 2 times 3, it's 6. But then on the left-hand side, I still have 2 and I still have 2 again there. If I put a 3 here, this 3 multiplied by 2 will give me a 6. So 6 for oxygen, balanced. But then now that iron is still not balanced. That's an easy fix again there. You just remove that 2 and you change that into A4. So if you remove the 2, and we change that into a 4, I now have 4 ions. So 4 ions, 4 ions. 6 oxygens, 6 oxygens. So both of these particular substances now, the left-hand side and the right-hand side, they are balanced. Now, our next one. Next question says, we need to name the reactants and products of the following reaction and calculate the number of atoms for each substance. So we have substance 1 on the reactants, we have substance 2 on the reactants again, and remember when we have more than one reactant, they are going to be separated by a plus sign. Then those two are going to react to form this substance. So we have iron oxide reacting with water to form iron hydroxide. Remember that this is your hydroxide, and when we name the substances or a compound, we'll start, when we're naming the OH, we'll start naming by the substance that is far to the left if both the substances making that compound they are nonmetals. So we'll start naming by the substance that is on the far left. In this case, it's going to be hydrogen, because we find hydrogen in group 1, and oxygen, we find that in group 7. So when we name, we start from the left-hand side to the right-hand side, hence hydroxide. So now, name the reactants and products of the following reaction and calculate the number of atoms for each substance. So this is your iron oxide. That's your iron oxide. And this is our famous molecule, water. And this is our iron hydroxide. Iron hydroxide. Now that we have named these substances, we now need to calculate their atoms. So on the left-hand side, calculate the number of atoms of each substance. So on the left-hand side, I have 2 ions. So 2 Fe, and then I have 3. Oh, sorry, I don't have 3. There's 3 of them here. And then remember, 3 multiplied by that. So there's 6 oxygen on the left-hand side. So there's 6 oxygen on the left-hand side. And then with regards to the hydrogens, how many do I have? 3 times 2. Again, there's 6 hydrogens on the left-hand side. So we have 6. Let's just do this. 2 Fe, 6 oxygen, and then also have 6 hydrogen. That's the left-hand side. Then the products. This 2 goes for everything in this particular compound. So that means I will have 2 Fe, which is balancing with that. Now, this is going to be 2 multiplied by oxygen and 2 multiplied by the hydrogen. And furthermore, we need to multiply the 3. The subscript 3 only goes for what's in the bracket. So because we said we multiplied 2 in the oxygen, there's a 2 and there's a 2. We then now need to multiply the 3 with the 2. So 3 times 2 is going to be 6 oxygen. So it's balanced. And then the last one, 3 times the 2 again is going to be 6 hydrogen. Remember, the 2 in outside the formula or on the left-hand side of the chemical compound goes for everything in that particular compound. Whereas the subscript, it is only for that specific atom. In this case, because they're in a bracket, it's for those 2 particular substances or those 2 atoms of oxygen and hydrogen. So we are seeing that now our atoms on the left-hand side are equals to the atoms on the right-hand side. So I'm going to stop here for now and quickly go for an ad break. I'll see you just after this.